Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us to the edge of everything, to that delicate, impossible place where something began from what we still call nothing. We'll drift together into the mystery of how the universe came to be, and whether there was ever truly a before. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each of us resting in our own little corner of the universe. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey together. Our gentle voyage back to the moment everything began. Every atom, every heartbeat, every dream, still folded into a single cosmic breath. If you've ever seen a picture of the Big Bang, you might imagine an explosion, bright, violent, bursting outward from some fiery dot. That's how most of us first pictured it. A cosmic firework, tearing through darkness and scattering the ingredients of stars. But that image, though powerful, isn't quite true. The Big Bang wasn't an explosion in space, it was an expansion of space. There was no single spot where it happened. It didn't light up the sky from one corner of the void. It happened everywhere, all at once, including in the room you're in now, and in every distant galaxy shimmering faintly at the edge of sight. It might sound strange. How can something expand everywhere? Imagine, for a moment, a loaf of bread rising in the oven. The dough itself stretches, and every raisin inside moves away from the others, not because the raisins are flying through the dough, but because the dough itself is swelling. Space behaves like that dough. It's not the galaxies racing through an empty void. It's the fabric of space itself that's stretching, carrying everything along with it. And just as the bread has no single center that everything expands from, the universe doesn't either. There is no middle, no outer edge, no place you could point to and say, there, that's where it began. The Big Bang didn't happen somewhere out there. It happened everywhere at once. If we follow that thread a little further, we arrive at a more puzzling thought. If the Big Bang happened everywhere, then asking where did it start becomes meaningless. And yet, so does asking what came before. Because time itself, our sense of before and after, was born in that same instant. There was no ticking clock waiting for the universe to appear. The clock began with it. The first moment of time was the first moment of everything. The British physicist Brian Cox once said that the Big Bang wasn't the beginning of a fire, but the beginning of time. It wasn't the spark that burned, it was the start of the ticking. Before that, there was no space for things to exist and no seconds for events to happen. The very question of what was before may be like asking what's north of the North Pole. It simply doesn't apply. Still, our curiosity doesn't give up so easily. Humans are wired to imagine before. We like beginnings and stories, causes and effects. We ask, if everything started somewhere, what was there before it? That question, quiet, persistent, almost childlike, is what has kept scientists awake for centuries. It's also what makes this such a beautiful mystery. The idea that maybe, just maybe, the word before loses its meaning at the edge of creation. To make sense of this, imagine time not as a straight line but as the surface of a globe. You can walk in any direction, yet eventually you'll find yourself looping back to where you began. There's no edge, no starting point, just smooth continuity. The same might be true for the universe. The Big Bang might not be the beginning of time, but simply one point along a larger curve. A kind of cosmic equator where something changes form, not something that begins. Let's soften that further. Picture the universe as a vast symphony. Before the first note, there isn't silence exactly, but rather the tension before sound, the potential for melody, waiting. The Big Bang could be that first note, the instant when potential became vibration, when vibration became structure, when structure became stars and dust and all the quiet places between. And because it happened everywhere, it also happened inside everything that would ever exist. Inside the atoms that now make up your hand, inside the light falling through your window, inside the warmth that lingers from your breath. The expansion that began 13.8 billion years ago, 13.8 billion, softly said, never really stopped. Space still stretches even now, imperceptibly, silently, like a sigh you don't notice until you're done exhaling. So when you look at the night sky, what you're really seeing isn't the aftermath of an explosion, but the continuation of that expansion. Every twinkling point, every soft glow is part of the same ongoing act of becoming. Light travels across billions of years to reach your eyes, and by the time it does, it's telling you a story that began long before Earth existed. It's worth pausing here to imagine what that first moment must have felt like, not in the sense of sound or light, but in rhythm. A swelling, a stretch, a slow unfurling from infinite density into vastness. There were no stars then, no atoms, no colour, only pure energy condensed into an almost unimaginably small space. Then, suddenly, space itself began to expand, and with it temperature and density fell. Out of that change came structure. Out of structure came light. Out of light came time, and everything that would ever measure it. The Big Bang, then, wasn't chaos breaking loose. It was balance finding room to move. A silent reorganization of everything that could exist. A soft beginning that still continues to echo, gently, through every corner of existence. As we drift further into the story, the path will carry us from this first breath of expansion into what might have caused it, how a hidden field of energy once rolled, like a wave, through that early universe and filled it with light and matter. But for now, you can rest in the thought that everything you know and everything you will ever see was part of one shared unfolding. An event that didn't just happen once upon a time, but is still happening quietly, even now. If we could peel back the layers of time, unrolling the universe like a scroll, there would come a moment when the writing simply fades away. The ink stops, the paper ends. Before that, there is no earlier line to read, because time itself hasn't begun its story yet. This is the moment that physicists call to equal zero, but even that phrase is a trick of language. It makes it sound like there's a before zero hiding somewhere behind the curtain, waiting for us to find it. Yet if time itself is part of the curtain, there is no behind. There is only the fabric as it starts to unfold. To imagine it gently, think of a clock that has never ticked. Its hands rest perfectly still, not because it's broken, but because the idea of movement doesn't exist yet. The first tick is not just the start of motion, it's the invention of the concept of before and after. That first tick didn't happen in time, it created time. Physicists sometimes describe this in equations, but for us, it might help to picture it instead as a dawn that slowly paints light onto darkness. Before that light, there was no night sky, no darkness to be compared with light at all, just a silence without contrast. The Big Bang marks the moment that silence became measurable, when the calm nothingness began to contain something that could change. At first, that change was so fast it defies imagination. The universe, smaller than an atom, expanded until it became vast enough to hold galaxies. In less than one part in a billion of a second, so quickly it feels wrong even to say in a second, space stretched by an unfathomable factor. We can't say 10 to the power of 50 times bigger, because such numbers don't carry feeling. It's easier to think of it as a breath that filled a whole cosmos before the next heartbeat could arrive. But what caused that first tick? What wound the clock? Some physicists suggest there may have been no cause at all, that causality itself, the chain of one thing leading to another, was born at that instant. Others imagine a more poetic scenario. That time, in its earliest form, curved back on itself. In this picture, the beginning of the universe isn't a hard edge or cliff, but a smooth bend, like the way the horizon curves beneath you when you look out from an airplane window. Stephen Hawking, with his collaborator James Hartle, described a version of this called the no-boundary proposal. It says that as we travel backward through time, asking what came before, we eventually reach a region where time itself becomes another direction in space. There is no before the Big Bang any more than there is a place north of the North Pole. It isn't forbidden, it's just meaningless. The beginning was not a wall, it was a curve. That curve might sound abstract, but it's not so different from how you experience beginnings every day. Think of the moment you wake up from sleep. You don't step abruptly from nothingness into awareness, you drift. Consciousness curves upward, slowly, softly. The start of time might have been like that too. Not a bang, but a dawning awareness of the cosmos itself blinking open. In those first fleeting moments, less than a trillionth of a second, energy and matter were not yet separate ideas. Everything existed as a smooth, dense sea of possibility. Temperatures soared beyond what any furnace could reach, numbers so high that writing them down feels pointless. Instead, think of it as pure brightness, so intense that light couldn't yet travel freely. The universe wasn't transparent. It was thick and radiant, like the core of a newborn star. Then, as it expanded, that energy cooled. Imagine steam condensing into droplets of water on a window pane. The same transformation was happening everywhere, but instead of water, it was fundamental particles, quarks, gluons, electrons, emerging from the haze as the universe exhaled. When the temperature dropped enough, these particles combined to form the first simple atoms. The moment the cosmos became transparent, light could finally move. That light, cooled and stretched by billions of years, is still around us today, as the faint microwave whisper we call the cosmic background glow. It's the oldest light in existence, the universe's baby picture. And all the while, the clock kept ticking. But what does that ticking really mean? Time doesn't flow like a river through the universe. It's the universe itself that flows, changing shape in ways that we measure as time passing. Einstein's equations once showed us that space and time are not two separate things, but one continuous fabric, space-time. When gravity bends space, it bends time too. When space expands, time expands with it. It's why cosmic time feels different from the way we experience seconds and hours here on Earth. The universe's clock doesn't keep regular beat. It stretches, slows, and drifts as gravity shapes its rhythm. If we could somehow stand outside of time and watch that first moment unfold, we wouldn't see an explosion. We'd see smoothness becoming motion, like a pond suddenly realizing it can ripple. We'd see space itself beginning to stretch, carrying everything with it, not outward but into itself. Every atom of your body, every star in the night sky, was once part of that same smooth expanse. There's something quietly comforting in that thought. That time, as vast and unstoppable as it seems, once fit into a single moment. That every clock, every sunrise, every memory began with one gentle tick that still echoes inside everything. In a way, you're not living after the Big Bang, you're still living in it, part of its continuous unfolding. Each breath you take is the same expansion, slowed down, embodied in flesh instead of space. As we drift further into the story, our quiet exploration now turns to what might have driven that incredible expansion. What hidden force or field lay beneath it, waiting to awaken? If time was the first rhythm, what was the drum that played it? What unseen energy pushed the universe outward and shaped the stage for everything that would come after? We'll follow that thread next to the strange idea that before there were stars, before there was even light, the universe was filled with something even more subtle, a field that existed everywhere and nowhere, humming softly in the dark, waiting for the chance to roll into motion. If you close your eyes for a moment, the darkness behind your eyelids might feel like nothingness. But even there, if you pay attention, it isn't truly empty. There's a pulse, a warmth, a sense that something lingers, your own heartbeat, the whisper of blood through tiny vessels, the faint hum of thought. Nothing is never truly nothing, even inside us. And, as it turns out, even in the universe's beginning, the same was true. When scientists speak of the vacuum of space, they don't mean a void in which absolutely nothing exists. In physics, the word vacuum is a little misleading. It doesn't mean blankness. It means the lowest possible state of energy. But even that lowest state isn't still. It trembles. It breathes. Tiny fluctuations ripple through it constantly, like gentle waves across a pond that never fully rests. This restless undercurrent is what we call quantum fluctuation. Picture it like this. At every point in space, even the quietest corner of the cosmos, pairs of tiny particles appear and vanish. They're not like the particles that make up you or me. They're more like brief thoughts that flicker through the mind of the universe, an electron and its opposite, a particle and its twin, born together and then instantly cancelling one another out. They appear because at the smallest scales, nature doesn't obey the same logic that we do. It doesn't ask permission to exist. It simply tries possibilities. You might imagine that this flickering happens at speeds far beyond comprehension, billions of times within a blink across every grain of space. But what matters more than the number is the pattern. Each tiny fluctuation adds a note to the background hum of reality. Together, they create what physicists call zero-point energy, the faint, irreducible buzz of existence itself. If you could somehow turn off all light, all motion, all heat, cooling the universe to absolute zero, the temperature where nothing moves, not even atoms, you'd still hear that hum. Even at zero, the quantum fields would continue to shimmer softly. There is no such thing as perfect silence in the universe. The void itself sings. And so, when we talk about the Big Bang, it becomes harder to say the universe came from nothing, because this nothing may never have been truly empty. It might have been this same humming quantum field, full of invisible potential, waiting only for the right moment to unfold. Some scientists suggest that our universe could have been born from a random quantum fluctuation, a moment when energy briefly concentrated in one spot long enough to trigger expansion. Imagine a quiet pond where, once in a great while, a larger ripple rises by chance, just high enough to spill over into something new. The laws of quantum mechanics allow such ripples to happen, not often, but inevitably. Physicist Edward Tryon once put it simply, the universe is simply one of those things that happens from time to time. He proposed that the total energy of the cosmos could be exactly zero. The energy of matter, the positive kind, and the energy of gravity, the negative kind, cancel perfectly. In that case, the entire universe could have arisen without ever costing anything. Creation, it seems, could be a balanced equation where the sum is still nothing. But maybe it wasn't just randomness. Maybe nothingness had structure, a geometry hidden beneath emptiness. Some physicists call this the quantum vacuum, a field filled with possibilities, each vibrating faintly like strings on an unseen instrument. In this view, reality didn't appear from nothing. It was always there, folded within a deeper invisible dimension, waiting for the first vibration to resonate. To bring that image closer, imagine a blank canvas. To the eye, it looks empty, but to the painter, it already contains every possible colour. The act of painting doesn't create colour, it reveals it. The Big Bang might have been the universe's first brushstroke, the moment potential began to take shape. And yet, even that description might be too comfortable, because before there were brushes or canvases or eyes to see, there were only the laws of physics themselves, if we can even call them laws without space or time to enforce them. Did those laws exist in some timeless form, or were they born with the universe, emerging alongside everything else? The truth is, we don't know, and perhaps that's what makes this question so profound. In the calm of the early universe, if early is even the right word, space itself may have been flat, featureless, infinite. There were no stars to twinkle, no dust to scatter light, no sound to echo. But within that stillness, something shifted. A delicate imbalance appeared. Energy curved space slightly, and that curvature began to feed on itself. Like the first breath after a long sleep, the universe expanded, slowly at first, then faster, as if waking from the deepest dream. This is the paradox at the heart of everything. Nothingness doesn't stay still. It is unstable by nature. Even the tiniest quantum tremor can grow into something vast. Every particle in your body, every atom of oxygen in the air you breathe, is a descendant of that restlessness. You are, in a literal sense, made from the ripples of ancient nothing. There's a poetic symmetry here. When you exhale, you release energy back into space, a small echo of the expansion that began it all. The same physics that governs the rise and fall of universes governs the flicker of thought, the warmth of a candle, the shimmer of sunlight on water. It's all part of one long chain of fluctuations, tiny changes amplified by time, becoming stars, becoming worlds, becoming you. So perhaps the universe didn't arise from nothing at all. Perhaps nothing was simply the word we used for a place too quiet to notice it was alive. A pregnant pause, holding its breath before creation began to speak. As we follow the thread a little further, that breath of potential will become more than metaphor. In the next step of our journey, we'll listen to how that hidden energy, the one vibrating softly in the background, might have rolled and spilled into motion, inflating the universe from smaller than an atom to wider than imagination in less than a whisper of time. The hum of the vacuum will become the rhythm of creation itself. There comes a point in every story where language begins to fail, where words seem too small for what they're trying to describe. For cosmology, that point is the beginning. The closer physicists tried to look at the instant of creation, the more their mathematics began to fall apart. The equations that had so elegantly described the dance of stars and the bending of light suddenly began returning nonsense. Numbers that reached infinity, densities without size, times without meaning. It was as though the language of physics itself forgot how to speak when it reached the first syllable of existence. This breakdown is what scientists once called the singularity, a point where the universe's density becomes infinite, its temperature unthinkably high, and its laws undefined. But infinite isn't really a number. It's a signpost that says, we've gone too far. When equations produce infinity, they're not revealing the truth of reality. They're gasping for air. They're telling us that our understanding stops here. The singularity isn't a thing that exists. It's a boundary, an edge of comprehension. To put it softly, imagine following a river upstream. You trace it through valleys and forests, past every fork and streamlet, until it narrows into a single trickle seeping from a rock. You can point to that spring and say, this is where the river begins. But the water itself didn't appear there by magic. It came from rain, from groundwater, from hidden channels you can't quite see. The Big Bang is that spring, and the singularity is the rock. It's the point where our map stops, but not necessarily where the story of water begins. Even Einstein's equations, so powerful they could bend space and time into harmony, began to unravel there. His theory of general relativity describes gravity as the curvature of space-time, but at the singularity that curvature becomes infinite. The fabric of reality twists in on itself until the geometry no longer makes sense. You could write it down as r equals infinity, but even that is just shorthand for confusion. Space, time, and energy become inseparable, and the usual rules, cause and effect, before and after, collapse together like a wave folding back into the sea. It's a humbling thing to realize that even the most brilliant minds could trace the universe so far back and still find a place where knowledge simply stops. Georges Lemaitre, the Belgian priest and astronomer who first proposed what he called the primeval atom, once described the birth of the cosmos as the day when space was filled with light and time itself began to count. His vision was not of a violent blast, but of a divine unfolding, a seed containing everything, cracking open into expansion. The mathematics seemed to agree until it reached that first instant when it could no longer keep pace with creation itself. Brian Cox once called this moment the silence between equations. That's where physics pauses and philosophy begins. When our symbols lose breath, we're left only with wonder. Perhaps beyond that boundary there is something the equations cannot yet see, a deeper pattern waiting for a new kind of mathematics to uncover it. For now, though, scientists do their best to listen to the echoes that remain. The universe itself is full of fossils, traces of its first moments still visible in the glow that fills the sky. When Penzias and Wilson accidentally discovered the faint hiss of cosmic microwave background radiation in the 1960s, they were, without realizing it, hearing the fading warmth of the Big Bang. That signal, stretched and cooled over 13.8 billion years, now hums gently at a temperature just above absolute zero, 2.7 degrees above it to be exact. It's the afterglow of creation, still bathing every direction of the sky in an invisible light. This discovery changed everything. Suddenly, the Big Bang was no longer just a theoretical idea. It had a trace, a fingerprint, something you could measure. The spots and ripples in that cosmic background tell us that the early universe wasn't perfectly smooth. Tiny differences in temperature, fractions of a degree, became the seeds of galaxies, clusters, and the grand structures we see today. Those imperfections were the universe learning to breathe, its first attempt at structure. But that raises a new question. Where did those tiny differences come from? Why wasn't the early universe perfectly uniform? The answer would eventually lead to a revolutionary idea, a theory so bold it would rewrite how we think about the beginning itself. That idea was inflation. Before inflation, physicists could only stare at the singularity and shrug. Their equations stopped at the threshold, like travellers at a locked gate. But with inflation, a new path opened, one that stepped carefully around infinity, replacing it with something smoother and far stranger. Instead of a single, sharp birth, inflation described a sudden expansion, space itself stretching at a speed faster than light, in a fraction of a second. Not an explosion, but a swelling. Not a chaos, but an orderly acceleration driven by a mysterious field of energy that filled everything and everywhere. In the language of mathematics, this energy was called a scalar field. In our language, it was more like a tide, rising invisibly, lifting the fabric of space until it could no longer resist. When the tide fell, it left behind waves, ripples that would later become stars, galaxies, and all the matter we know. If that sounds almost mystical, it's because it blurs the line between physics and philosophy. The idea that something can come from nothing, that the equations themselves might falter just as reality takes its first breath, is difficult to hold in the mind. But in that difficulty lies the beauty of it. The Big Bang isn't just a story about energy and expansion. It's a story about the limits of knowing, about standing on the edge of understanding and feeling the silence that waits beyond. As we drift further into the story, we'll follow that silence to the moment it began to vibrate, to the mysterious field that filled the newborn universe with potential, and to the instant when that potential finally let go. Because if the singularity was where equations lost their breath, inflation is where the universe began to exhale. Imagine for a moment a universe smaller than a seed, not a star or a cloud or even a speck of dust, just a space so tiny and dense that every particle, every future planet and thought and breath was folded inside it. The temptation is to picture this as a bomb waiting to go off, as though the Big Bang were a kind of cosmic firecracker lighting the fuse of creation. But the truth is quieter. It didn't explode, it expanded. The story begins not with a bang, but with a slow, invisible breath. At that time, space itself was a kind of field, a sea of invisible energy filling everything that existed. And within this sea lay tension, like a stretched string, like air before a storm. Nothing happened for what we would call a long time, though time didn't yet mean what it means now. Then something shifted. That field rolled, like a wave moving downhill, and as it did, space followed. This is the idea that physicist Alan Guth first proposed in the early 1980s. He called it inflation, but that word doesn't capture how gentle and profound it really was. In less than a fraction of the smallest imaginable moment, less than a trillionth of a second, the universe swelled from smaller than an atom to something large enough to hold galaxies. It's impossible to imagine a number like that. It's better to think of it as the blink of the cosmos' first eyelid, opening to light that did not yet exist. To help you picture it, imagine a balloon being filled with warm morning air. As you breathe into it, every dot on its surface moves away from every other dot, not because the dots themselves are travelling, but because the surface beneath them is stretching. The same was true for space. The galaxies we see today didn't blast apart through emptiness. They drifted apart because the fabric of space itself was expanding. And just like the balloon, the universe had no centre and no edge. It was everywhere, growing all at once. The energy of that invisible field powered everything. As it rolled toward stability, its energy was released as heat, what scientists call reheating, though it was more like the first dawn after endless night. That heat filled the universe with particles of light, matter, and radiation, all in a chaotic but creative dance. You might imagine it as the moment a cold, dark ocean finally catches fire. The darkness didn't end because something new entered. It ended because the universe learned to glow. At this early stage, there was no distinction between the physical and the abstract. The boundaries we take for granted, between space and energy, between energy and matter, had not yet formed. There was only a kind of pure potential, a single note of creation waiting to resonate. And as it expanded, it cooled. And as it cooled, that note began to split into harmonies, the first atoms, the first forces, the first ingredients of everything that would follow. If you want to imagine how quickly this happened, think of it like this. The entire expansion, this unimaginable swelling of reality, took less time than it takes light to cross a grain of sand. During that instant, space expanded by a factor so large it defies language. More than a number with 50 zeros could describe, but that's not the point. What matters is that this expansion set the stage for everything else. Without inflation, the universe would have been a chaotic patchwork, some places dense, others empty, filled with wild temperature differences. Instead, inflation smoothed it out, stretched it flat, and prepared it for the slow, graceful unfolding that would come next. It's strange to think that smoothness could give rise to complexity. but that's how it works. When a pond freezes, it looks flat and still, yet beneath the ice, ripples and imperfections form the seeds of cracks and currents. The same thing happened in those early moments of inflation. Tiny fluctuations, minute differences in density smaller than any speck of dust, were stretched across space, frozen into place as permanent imprints. Billions of years later, those slight unevennesses would become the galaxies, stars and planets we know. Even the smallest randomness can become magnificent when the universe has time to grow it. There's something poetic in that. Creation, it seems, doesn't begin with thunder but with a whisper. The first act of the cosmos was not violence, it was balance shifting, like a sigh after holding your breath too long. Inflation wasn't a bang but a release. Space wasn't born from chaos, it relaxed into being. And this gentle beginning solved puzzles that had haunted astronomers for decades. Why does the universe look so similar in every direction? Why is the cosmic background light so uniform, as though everything once shared the same warmth? Inflation provided the answer, because everything did share that warmth. Before inflation, every part of the universe was close enough to touch. When it expanded, that shared temperature stretched outward, filling the sky with harmony. Today, when we look deep into the cosmic background radiation, the soft microwave glow that fills the night, it's like looking into that first breath. Every photon, every flicker of light that reaches our telescopes carries the memory of those earliest moments. They whisper that the Big Bang was not a single blast, but a long, steady exhalation, a transformation from tension to motion, from potential to reality. It's easy to forget when hearing the word bang that the universe began in silence. There was no sound to accompany this expansion. Sound needs air and there was none. It wasn't an explosion. It was a change in the rules of existence. It was geometry learning how to stretch. You might picture it as a piece of fabric being woven in real time, threads appearing, expanding, crossing one another in intricate ways. Each crossing point is a place, a future star or galaxy. Each thread carries the same origin. The loom is the field of inflation itself, weaving the cosmos one vibration at a time. When the field finally relaxed into calm, its energy transformed into matter and light, leaving behind the delicate structure of space-time itself. The universe had found its rhythm, its first steady heartbeat. So, the next time you hear the term Big Bang, you can imagine something gentler. Picture not an explosion, but the sudden warmth of sunlight through cold air, or dough rising quietly under a kitchen towel, or the hush just before dawn breaks. The beginning of everything was not a shattering of silence, it was the silence becoming alive. As we drift further into the story, that silence will begin to sing. The ripples left by inflation, the faint wrinkles of quantum foam, will become the music of galaxies, the melody of structure, and the first true evidence that even chaos, when stretched by time, can find harmony. If you've ever watched frost form on a window, you know that beauty can emerge from the smallest imperfections. The ice doesn't grow in perfect order, it branches and curls, following invisible patterns in the air. What begins as random specks of cold soon becomes a lacework of delicate geometry. The early universe behaved in a strangely similar way. Out of a sea of near-perfect smoothness, it found a way to shape itself through tiny fluctuations, microscopic ripples that, in time, would grow into galaxies, stars, and worlds. These first ripples were born from the same quantum trembling that once filled the nothingness. During the brief, luminous breath of inflation, those tremors were stretched across space. What had once been smaller than an atom became vast enough to shape entire clusters of galaxies. A wrinkle in the fabric of space-time, smaller than a whisper, became a riverbed along which matter would later flow. It's difficult to imagine how something so small could have such an enormous legacy. The key is expansion itself. When the universe inflated, Every fluctuation, every tiny variation in energy, was pulled apart and frozen in place. Imagine blowing a bubble in a sink full of soap foam. As it grows, the fine textures of the foam stretch outward, locking the patterns into a larger and larger scale. Inflation did the same, magnifying the quantum foam into the architecture of everything. You can think of it as music if you like. Each quantum fluctuation was a note, vibrating for an instant, then carried outward by the wind of expansion. Inflation amplified those notes until they became the harmonics of the cosmos. The lowest, deepest tones became the vast clusters of galaxies. The higher, gentler ones became the filaments of dust and gas between them. Even chaos, it seems, can hum in tune. The evidence for this ancient melody still fills the sky. When we look at the cosmic microwave background, the soft, uniform glow that stretches across the heavens, we're not just seeing light, we're seeing the fossilized vibrations of the universe's first song. Those faint colour differences you might see in scientific maps, the slight shades of red and blue, are temperature variations so tiny they amount to just a few millionths of a degree. Yet from those subtle shifts, every star was born. To put it in gentler language, the universe was a drum skin made of space-time, struck once by the energy of creation. The vibrations that followed never fully faded. They stretched and cooled, becoming galaxies, constellations, the pale shimmer of the Milky Way. Every light we see in the night sky is part of that echo, a glowing remnant of the first rhythm. It's astonishing to think that the geometry of our entire existence might trace back to the quantum equivalent of background noise. If we could listen to it, it would sound like a faint static, like the hiss between radio stations. But when that static was magnified by inflation, it gained structure. Some frequencies grew stronger, others faded. The universe composed itself like a piece of improvisational music, guided by probability rather than purpose. In this way, randomness gave birth to order. It's a comforting thought, especially on nights when life feels unpredictable, that even disorder has a melody hidden inside it. The galaxies that wheel across the sky are not accidents, they are the natural consequence of imperfection, stretched and sung into form. The physicists who study these ancient harmonies sometimes speak of a power spectrum, a statistical pattern describing how strong each note was in that early cosmic music. The peaks and valleys of that spectrum correspond to different scales of structure, where galaxies would form, where clusters would gather, where voids would stretch. But we don't need the mathematics to feel its meaning. We only need to step outside on a clear night and look up. Each point of the light is part of the same composition. The stars are chords, the galaxies harmonies, the dark spaces between them pauses in the song. This pattern also reveals something deeply human. The universe doesn't strive for perfection. Perfection is sterile. It leaves nothing to grow from. It was the tiniest unevenness, the faintest off-key note that made creation possible. If the early universe had been perfectly smooth, gravity would have had no reason to clump matter together, no stars would have formed, no planets, no oceans, no you. In a perfectly even cosmos, there would only be silence. Instead, the universe began slightly flawed, and because of that, it became interesting. It became alive. You might even say that existence itself depends on imperfection. Every star that twinkles is an echo of that original imbalance, glowing because the cosmos dared not to be perfect. When we translate this story into sound, the notes that inflation left behind still hum faintly through space. Radio telescopes can detect it, the gentle static of microwaves coming from every direction. This light has travelled for nearly 14 billion years, stretching as the universe expands, cooling as it moves. Its wavelength has grown so long that our eyes can no longer see it. But it's there, bathing us constantly in the ancient warmth of creation's afterglow. If you close your eyes right now and imagine the faintest possible hum, the kind that isn't heard but felt, you'll be closer to understanding it than any formula could bring you. That hum is the bridge between everything that was and everything that is. It connects your heartbeat to the echo of the Big Bang, your breath to the breath of the universe. So the next time you hear the word nothing, remember that even nothing has texture. Even silence has tone. The universe began not with a perfect void, but with a trembling, a soft vibration that refused to fade. From that tremble came all structure, all time, all meaning. As we follow the thread a little further, that trembling field will take on a new identity. The hidden source of motion, the invisible hand shaping reality. We'll see how this quiet energy, spread everywhere and nowhere, transformed itself into matter, into heat, into the architecture of being. It was the field that dreamed of stars, and in its dream, everything began to shine. There's a quiet mystery that lingers behind everything we've talked about so far, a question that hums like the low note under a song. What powered the expansion itself? What breathed motion into that early, fragile silence? Physicists call it the scalar field, but the name hardly does it justice. Imagine instead something more poetic, a kind of invisible weather that fills all of existence. It has no colour, no direction, no temperature, yet it shapes everything that will ever be. You might picture it as the air of reality, the unseen medium that lets creation happen. In the earliest moments of the universe, this field didn't move evenly. It was perched high on an energetic slope, like a ball balanced on the crest of a hill. For a timeless pause, it stayed there, holding the universe in tension. Then, softly, it began to roll. As it rolled, space itself followed, stretching outward like a sheet of silk being pulled from every side at once. That gentle motion, this slow roll down the hill, is what drove the inflationary expansion we spoke about before. But even here, words like driven or caused feel too forceful. Nothing was pushing or pulling. The field was simply relaxing, falling into a lower, calmer state. As it did, the energy it released became the stuff of everything: matter, light, and eventually, life. If you want to imagine it, think of an early morning when fog still clings to the grass. The air feels thick, heavy with moisture. Then, as the first sunlight touches it, the fog begins to lift, releasing droplets into shimmering air. Inflation worked a little like that. The fog was the high-energy field, dense, featureless, full of potential. The sunlight was its shift into balance, and the lifting mist became the radiation and matter that would one day form galaxies. Physicists describe this transformation as a phase transition, but that phrase sounds colder than it feels. A better way to think of it might be the way water transforms into ice or steam. Nothing new is created. The same molecules simply take on a different form. One phase flows into another, and the world around it changes with it. When the cosmic field shifted phase, the universe did too. It moved from stillness to motion, from potential to pattern. At the moment the shift began, the universe was unimaginably hot, its temperature beyond the scale of any furnace or star. Instead of saying 10 trillion degrees, it's easier to think of it as the heat of all possible heat, condensed into one infinite glow. In that heat, particles formed and vanished like raindrops sizzling on a pan. Quarks, electrons, and photons danced in a chaotic blur, continually colliding, transforming, and reappearing. But as the universe expanded, that energy began to thin. The collisions slowed. The light had more space to travel. The cosmic firestorm softened into a golden fog, then into a transparent sky. It was in that cooling that structure could finally begin. You might say the field dreamed itself into stability, and in that dream, the seeds of stars were planted. There's an elegance to this that feels almost intentional, though it's the pure result of physics. The field didn't have a purpose, it simply followed the path of least resistance. But in doing so, it sculpted a universe capable of meaning. When its tension released, it created imbalance, and imbalance allowed complexity to grow. Like a stretched string that vibrates when loosened, the field's relaxation became the melody of existence. We can still feel its presence today. Physicists believe remnants of that same field, or others like it, still linger, permeating space. They may even account for the mysterious dark energy that now drives the accelerated expansion of the cosmos. The universe hasn't stopped expanding. It simply found a quieter rhythm, like the long, deep breath after a sigh. This idea that an invisible field could shape the entire cosmos might sound abstract, but it's not so different from everyday life. Consider heat. You can't see it directly, but you feel its influence in everything, from the warmth of your hands to the gentle shimmer above asphalt on a summer day. The field that birthed the universe was a kind of cosmic heat, a background condition so fundamental that it defined what something even meant. When we look at the world through this lens, it's hard not to see everything as connected. The air around you, the light on your walls, the rhythm of your pulse, they're all distant consequences of that same original transition. The energy that once filled the universe now beats in every heart, hums in every atom. Every flicker of life is an echo of that field finding new ways to express itself. In a way, you could say the field never vanished. It simply transformed. It became the particles that make up your body, the forces that keep your feet on the ground, the photons that travel from your lamp to your eyes. When you move, breathe, or think, you're carrying forward that same energy now arranged in infinitely intricate forms. The universe's expansion may have slowed, but creation never truly stopped. It continues in every exchange of warmth, every flicker of consciousness. There's a line from the astrophysicist Carl Sagan that captures this perfectly. We're a way for the cosmos to know itself. You could also say we're the field remembering its own dream. And yet, some physicists believe the dream might never have ended. Inflation, they suggest, may not have completely stopped. It may continue endlessly in regions beyond our cosmic horizon. While our own bubble of space cooled and settled, other bubbles might still be forming, rolling down their own slopes, expanding into universes with different constants, different forms of light, perhaps even different notions of time. If that's true, then the field's dream is still unfolding somewhere out there, in infinite variation. It never truly rested. It simply learned to imagine. Each bubble, each universe, could be one verse in a poem without end. As we drift further into this story, we'll explore what that endless dreaming might look like. A garden that grows forever, blooming with worlds we'll never see, each carrying its own reflection of the same gentle beginning. If you could stand outside the universe and watch it grow, not from a single point, but from all points at once, you might see something that looks less like an explosion and more like a field of endless blooming. Space itself would unfurl like petals opening in every direction, each blossom glowing for a moment, then drifting gently apart. This is the vision behind one of the most quietly astonishing ideas in modern cosmology: eternal inflation. The word eternal here doesn't mean time stretching forever in the way we usually imagine. It means that the process of creation never really stopped. The inflation that expanded our own universe may have ended billions of years ago, but the mechanism that caused it could still be happening elsewhere, again and again, endlessly, in a cosmic garden that grows without a gardener. Imagine boiling water on a stove. Tiny bubbles appear, expand and separate, each filled with vapor. The surface of the water is the larger space, the inflating field, and each bubble is a separate universe, self-contained, disconnected from its neighbors. The water keeps boiling, the bubbles keep appearing, and no two are quite the same. That's how physicists describe the multiverse: a sea of universes, each born from a pocket of space that stopped inflating while the rest continued. In our universe, the one we inhabit, this inflation slowed and cooled enough to allow matter, light, and time to stabilize. But beyond our cosmic horizon, where our instruments can't see, inflation may still be roaring silently onward. Space there continues to stretch faster than light could ever travel, creating new bubbles with every passing fraction of a second. There could be countless of them, more than the number of grains of sand on every beach on Earth, multiplied again and again until counting itself loses meaning. Each bubble is a new world with its own laws of physics. In one, gravity might be stronger. In another, atoms might never form. Some might burn bright with stars. Others might exist in quiet darkness, never finding a way to shine. Most would be barren, but some, by chance, would be gentle enough, balanced enough for galaxies to form, for chemistry, for life. We, it seems, live in one of those rare calm bubbles where the math works out just right for meaning to arise. You might be tempted to think of these universes as scattered through some enormous three-dimensional space, like lanterns floating through a night sky. But that isn't quite true. They don't sit next to one another in a larger void. They are separate pieces of space-time itself, each with its own dimension of distance, its own flow of time, its own beginning and perhaps its own end. The boundaries between them are not walls but unreachable distances, where space expands faster than even light can cross. It's a strange thought, but a strangely comforting one. The cosmos in this view is not a singular event but a vast self-renewing process, a garden that never stops planting new seeds. Ours is simply one bloom in an infinite meadow, still expanding, still alive. When scientists first realized this possibility, it changed the question they asked about the Big Bang. Instead of, why did it happen? The question became, why did it happen this way? Why do we have this particular mix of forces, this gentle balance that allows stars to burn just long enough for life to appear? The answer may lie in selection, not intention. Out of countless universes, we happen to be in one where the conditions permit us to ask the question at all. If gravity were a little stronger, stars would collapse before planets could form. If it were weaker, matter would never clump together at all. We exist in the narrow zone where the cosmic recipe allows observers to taste it. In a poetic sense, the universe seems to be fine-tuned for awareness, but not because it was designed that way. Rather, awareness can only exist in a universe where things line up just so. It's not the cosmos that needs us. It's we who need the cosmos to be this calm, this balanced. Out of infinite variations, we are one successful bloom among endless petals of possibility. If this sounds abstract, let's return to something tangible. Imagine standing in a vast meadow at night. Around you, millions of fireflies blink in and out, each lighting for a moment, then vanishing. You can never see more than a few at once. But you know the meadow extends beyond the hill, full of unseen glimmers. That's what the multiverse might be like, countless universes flickering into being, each with its own rhythm, its own brief illumination. Ours happens to be one that stayed lit long enough for someone inside it to notice. Eternal inflation is an idea so large it's almost difficult to hold in a single thought. It suggests that the universe is not a single canvas but an endless painter, forever experimenting, forever spilling colour across invisible walls. And yet, this infinite creativity doesn't feel chaotic. It feels patient, peaceful, like the tide, rising and falling in rhythms too vast for us to perceive. In the quietest sense, it also changes how we see ourselves. If creation never stops, then existence itself is not a miracle that happened once. It's a natural rhythm, repeating in every direction. The same physics that sculpted this world may be sculpting others, endlessly. The laws we study, the stars we watch, the breath you take, all a part of a pattern so wide that even infinity has room to stretch. When you think of it that way, the universe becomes less like a singular story and more like a song that keeps finding new verses. Each verse echoes the one before but sings it differently. Ours might not be the first and certainly won't be the last. Somewhere, beyond horizons we can't yet reach, space is still blooming, time is still beginning, and the garden grows on. As we follow the path further, we'll step from this infinite meadow of universes into other visions of creation, cycles that collapse and rise again, universes that breathe instead of bloom, cosmoses that die not with an end but with a promise of renewal. For the story of beginnings, it seems, never truly ends. If you sit beside the ocean long enough, you begin to feel its rhythm. Each wave rises, folds into itself and falls away, only to rise again. It's a pattern so ancient that it feels eternal, an ebb and flow that never truly stops, only changes shape. For some cosmologists, that rhythm is not just poetry, it may be the nature of the universe itself. Perhaps the cosmos too breathes. Perhaps it expands and contracts, not once but endlessly, each collapse followed by a new beginning. This idea is known as the cyclic or bouncing universe, and it offers a different way to think about creation. In this picture, the Big Bang was not the first event, but merely the latest inhale in an infinite sequence of breaths. Before it, another universe might have expanded, aged, and then fallen back upon itself, squeezed by gravity until everything, stars, galaxies, even the laws of physics, compressed into a state of unimaginable density. When that pressure became too great to bear, it rebounded, triggering the next expansion. And with that rebound, time began anew. The concept isn't new. Ancient myths have long told of worlds that die and are reborn, the phoenix rising from ashes, the serpent eating its own tail, the Hindu kalpas where universes breathe in and out across eons. Modern physics, however, has given those old intuitions new mathematics. In a framework called loop quantum cosmology, scientists discovered something remarkable. At extremely high densities, gravity may no longer pull inward. Instead, it could push outward. The same force that once drew everything together could become repulsive, preventing the universe from collapsing into a true singularity. To describe it without symbols, imagine that space-time is not a smooth fabric, but a weave made of tiny loops, threads so fine that they form the structure of existence itself. As the universe contracts, those loops resist being compressed beyond a certain limit. When that limit is reached, the pressure reverses and the universe bounces outward. The result is a cosmic heartbeat. Collapse, rebound, expansion, cooling, then again and again forever. It's an elegant answer to one of the great paradoxes of cosmology. If everything came from the Big Bang, what came before it? In this view, there was no before in the usual sense. There was simply another cycle, another universe rising and falling like a tide. Each bounce wipes the slate clean, yet perhaps not entirely. Tiny traces of information, like faint fingerprints, might carry through from one cycle to the next, influencing how each new universe forms. If that's true, then we might be living in a cosmos with a memory, a universe that has done this countless times before. Every star might be the latest version of a pattern billions of cycles old. Every law of physics could be a melody refined across infinite rehearsals. To bring this idea down to earth, imagine a vast forest after a wildfire. At first, it seems everything is gone, reduced to ash and quiet smoke. But then, after rain, shoots of green begin to push through the soil. Life reclaims what was lost, reshaping itself in new forms, never identical, but always familiar. The universe may follow a similar path. Each collapse clears the stage, each rebound begins a new play. The actors change, but the performance continues. This vision of cosmic renewal also reshapes how we think about endings. In a purely expanding universe, everything eventually grows cold and dark, a slow fade into emptiness known as the heat death. But in a cyclic model, death is only intermission. The heat death of one universe is the ignition of the next. Entropy resets. Time folds in on itself, only to stretch outward once more. Creation and destruction become partners in an endless dance. Of course, the physics behind this is still uncertain. We don't yet know whether gravity truly reverses at extreme densities, or whether the fabric of space-time can bounce rather than tear. But there are hints, patterns in the cosmic background radiation that some claim show echoes of previous cycles. They're faint, ambiguous, like distant drumming through fog. Whether they're real or illusion, the possibility is enough to inspire wonder. Maybe the Big Bang was not a singular beginning, but one note in a repeating rhythm. And if that's the case, then time itself might be circular. The universe could have no ultimate start or finish, only endless renewal, each expansion carrying within it the seeds of its own contraction. It's a comforting symmetry, one that feels almost natural. After all, everything we know follows cycles: the beating of the heart, the turning of seasons, the waxing and waning of the moon. Perhaps the cosmos is simply the largest example of the pattern written everywhere. There's a gentleness in this picture. It tells us that even destruction has purpose, that collapse is only the other side of creation. When the universe grows weary, it rests. When it rests, it gathers itself for the next breath. And in that rhythm lies eternity, not an endless line, but an infinite loop spiraling through ages beyond imagining. You can almost feel it if you listen carefully. The pulse of being, the rise and fall of existence. Not the ticking of a clock, but the slow tidal motion of everything. As we drift further into the story, the path now carries us to another version of the same idea, one not of collapse and rebound, but of encounter. A vision where the birth of a universe is not a breath, but a collision. In that telling, our cosmos was born not from itself, but from the gentle brush of worlds in higher dimensions, and when those invisible planes touched, space awoke and another kind of beginning began. Imagine, for a moment, two vast sheets floating through an invisible ocean, each silent, each endless, drifting side by side but never quite touching. They are weightless and flat, like veils of light moving through darkness. You could travel along one forever and never sense the other, until at some point beyond comprehension, they draw near enough for their surfaces to brush. In that brief, miraculous contact, energy blooms, space ignites, a universe is born. That is the essence of what physicists call the brain theory of creation, a picture so strange that it almost sounds like a dream, and yet it might explain why the Big Bang happened at all. The word brain comes from membrane, and in this theory, our entire universe is one such surface, floating within a higher dimensional space. We exist upon it, made of it, moving with it, but never seeing what lies beyond its plane. To bring this into gentler focus, think of a soap film stretched between two wires. To you, it looks thin and shimmering, yet within that surface there's motion, colour, tension. Now imagine that another soap film drifts close to it. When the two touch, there's a flicker, a shimmer, and then the energy of the contact ripples outward. What was once invisible suddenly shines. That is, in simple terms, what might have happened at the birth of our universe. In this model, sometimes called the epirotic or brain collision theory, our Big Bang wasn't beginning from nothing. It was the result of two higher dimensional brains brushing against one another in a space beyond what we can perceive. Their collision released immense energy, filling our universe with light and matter. Then, as they drifted apart, expansion began, and time flowed forward. If that sounds strange, remember that our senses only allow us to perceive 3 dimensions of space: length, width, and height. But according to theories of higher dimensional physics, there could be more, directions we can't point to, like shadows of movement folded behind the fabric of our world. Our universe could be a 4-dimensional brain floating within a 5-dimensional bulk, just as a flat sheet of paper floats within 3-dimensional air. You can't step off the page, but the air around it still exists. In the same way, we can't reach beyond our universe, but perhaps something else is there. Another brain, another surface, moving through the same greater space. Every so often, maybe every trillion years, those brains approach, touch, and create another Big Bang. Not the first, not the last, but one of many gentle collisions in the infinite dark. There's an oddly graceful beauty to this idea. It transforms the Big Bang from a singular explosion into a moment of contact, a cosmic kiss, fleeting yet creative. The energy released by that brush of dimensions would have been enormous, far beyond what words like hot or bright can express. Yet it was not violence, it was renewal. In that instant, the potential energy stored in the brain's motion converted into the raw materials of a new cosmos. Space expanded, time began, and the ripples of that encounter became the galaxies we now see scattered across the sky. You could think of it as thunder following lightning. The lightning is the contact, instantaneous and powerful. The thunder is the echo that follows, spreading out slowly across the air. In the same way, our expanding universe is the echo of that primordial meeting, a slow-motion thunderclap that continues to roll through space 14 billion years later. The epirotic idea also offers an answer to a puzzle that has long haunted physicists: why the Big Bang happened in such an ordered way. If universes arise from random chaos, why was ours so smooth, so finely balanced between expansion and collapse? The brain theory provides a possible reason. As the brains approached one another, the forces between them smoothed out irregularities, like a taut sheet being pulled flat. By the time they touched, the collision created a uniform burst of energy, setting the stage for a well-balanced universe. It's tempting to imagine what might happen in the space between those collisions. When the brains drift apart, the universe cools, expands and matures. Stars form and fade, galaxies spin and merge, civilizations rise and fall. Then, after unimaginable ages, far longer than the lifetime of any star, the brains might begin to drift back toward each other, drawn by forces we cannot feel. Slowly, over eons, they approach again. When they touch once more, another Big Bang blooms, and a new cosmos is born. In that way, even this theory becomes another kind of cycle. The universe not as a single breath, but as a heartbeat echoing through higher dimensions. This is not the first time science and imagination have met so closely. Ancient philosophers once imagined creation as the friction of opposing realms, the meeting of heaven and earth, light and darkness, fire and void. Now physics gives that poetic intuition new meaning. Perhaps creation really is the meeting of worlds, only those worlds are not mystical but geometric, folded within the unseen dimensions of reality. To make the image even softer, imagine standing between 2 enormous curtains in a still room. You can't see the air moving, but you can feel a subtle pull as one curtain stirs toward the other. If, one day, they brush together, you would hear a whisper of sound. In the same way, our universe might be the whisper left behind when invisible curtains of reality touched for a moment in eternity. What lies between those brains is still a mystery. Some physicists call it the bulk, but that word feels too heavy for something so quiet. Perhaps it's better to think of it as a calm sea in which all universes drift, each one a ripple on its surface, each collision another wave, and in that sea, perhaps there are countless other brains, floating through unseen currents, waiting for their own gentle collisions. The idea may sound extravagant, but it reminds us of something profound. Even the most incomprehensible theories are at their core stories of relationship. One surface meets another, energy moves, light awakens. In that simple pattern of touch and release lies everything: the creation of stars, the flow of time, and the possibility that existence is not isolated but connected through invisible threads of dimension. As we follow the thread a little further, our quiet exploration now turns from these collisions in higher space to a different kind of infinity, one without walls or edges, where time itself bends until it becomes part of the same smooth surface as space. We'll see how, in the mind of Stephen Hawking, the universe could be finite but unbounded, like the curve of a globe that has no starting line and no beyond. A universe with no edge and no before, only continuity, like a circle drawn in light. If you walk far enough in one direction on Earth, eventually you find yourself back where you started. There's no wall, no cliff at the end of the horizon, only the quiet realization that the journey has curved into a circle. It's the simplest example we know of something that is finite yet has no edge. And perhaps, said Stephen Hawking, the universe itself is built the same way. The image of the Big Bang as a beginning implies that time itself started with a sharp boundary, like a movie that suddenly fades in from black. But Hawking and physicist James Hartle propose something softer, something that feels less like a birth and more like a transformation. According to their no-boundary proposal, the universe might not have an edge in time any more than Earth has an edge in space. Instead, as we trace history backward toward the Big Bang, time simply curves into another dimension, merging seamlessly with space. To picture it, imagine standing at the North Pole. You can travel south in any direction, but there's no such thing as north of north. It's not that you can't go there, it's that there doesn't exist. Similarly, if you could somehow travel backward in time toward the Big Bang, you'd reach a point where the distinction between before and after disappears. The universe doesn't end. The concept of before just ceases to make sense. Hawking described it as the ultimate rounding off of creation. Instead of an abrupt beginning, an edge where physics breaks down, the cosmos would have a smooth, closed geometry. Time and space would be woven together into a continuous whole, a four-dimensional curve without corners. In such a universe, there was no instant when the light switched on. There was only a gradual unfolding, like dawn blending into morning. It's an idea that defies our usual sense of logic, but not our sense of beauty. We're used to thinking in straight lines: birth, life, death, sunrise, noon, sunset. But the universe, if it truly has no boundaries, may not follow the line at all. It may follow the curve, the endless loop, the soft symmetry that never quite stops. To help this feel real, imagine blowing up a balloon once more, but this time not the material balloon itself. Imagine being a two-dimensional creature living on its surface. As you walk around, the surface feels infinite. You never reach an edge. But in truth, your world is finite, curved into itself. The no-boundary proposal extends this logic into time. The Big Bang wasn't a singular point in the past, but a smooth curve where space transitioned into time, like the rounded tip of a sphere. At that moment, if the word even applies, conditions were extreme but not infinite. Temperatures and densities were very high, yet still describable. The universe, rather than bursting from nothing, simply emerged from a more symmetrical state, where time itself was one of the directions of space. And once that symmetry broke, time began to flow in the way we experience it, forward, measurable, full of change. What's remarkable about this picture is that it removes the need for something to start the universe. There's no moment that requires a cause because there was never a first tick of the clock. It's like asking what caused the North Pole. The question doesn't quite fit. The pole isn't an event, it's a feature of geometry. In the same way, the universe might simply be self-contained, requiring nothing outside it to spark its existence. This doesn't make the cosmos any less mysterious. If anything, it deepens the wonder. A universe without boundaries feels both vast and intimate, like an ocean with no shore. Every point in space becomes part of a continuous whole, each connected to every other by the curvature of reality. We are not separate observers standing at a distance, but patterns of the same fabric, folded into the same curve. Even in such a smooth model, irregularities still matter. As quantum fluctuations, those tiny tremors in the vacuum rippled through the newborn universe. They left faint imprints in that curve. Those imprints became the seeds of galaxies, just as we've seen before. But this time, they were laid onto a surface with no beginning or end, like brushstrokes on a spherical canvas. The whole of existence became a self-painting sphere of energy, slowly cooling into light. To Hawking, this wasn't just a mathematical curiosity. It was a philosophical turning point. If the universe has no boundaries, then it also has no outside, nothing beyond it to dictate its conditions. It exists according to its own rules, self-contained and complete. The universe, he once said, would simply be. What place, then, for a creator? That question doesn't dismiss the idea of meaning or wonder. It reframes it. Instead of seeing creation as something done to the universe, we can see it as something the universe is always doing. The act of existing is itself the miracle. It's tempting to feel small in this vastness, but in another sense, the no-boundary view makes everything feel closer. You're not at the centre of the universe, but neither are you at its edge, because there are no edges to speak of. The same curve that defines space also holds you, just as it holds every star and atom. You're part of the roundness of being, inseparable from the total shape of existence. If you could somehow step outside this curved universe and look at it as a whole, you might see something astonishing. A four-dimensional sphere, smooth and luminous, expanding in every direction yet with no beginning, no end, and no outside. A self-contained glow, a thought that contains itself, dreaming of time while being timeless. In the stillness of that vision, creation no longer feels like a single event in the past. It feels ongoing. Every expansion of space, every spark of starlight, every breath you take, continues that same curve forward. The universe doesn't need an edge to grow. It grows from within, unfolding its own geometry moment by moment. As we follow the thread a little further, we'll step from this idea of a boundless beginning into something equally haunting. The possibility that time itself might have a twin. A mirror image, moving not forward but backward. Somewhere, perhaps, another dawn is unfolding in reverse, retracing our every motion, every star, every spark, toward a different kind of symmetry. There is a peculiar comfort in symmetry. We see it in snowflakes, in the reflection of mountains across still water, even in the rhythm of our own heartbeats. Nature seems to adore balance. It arranges petals in even spirals, pairs electrons in orbits, folds galaxies in mirrored arms. And yet, when we look at time, the one thing that defines our lives, it seems to flow only one way. The arrow moves forward, never back. Cups shatter, but never reassemble. We grow older, not younger. But could this direction we call forward be just half the story? Some physicists believe it might be. They suggest that our universe could have a twin, one that moves through time in reverse. A mirror cosmos, not opposite in space but in temporal flow, born from the same beginning yet travelling the other way. It's called the CPT symmetric model, where three of nature's deepest symmetries, charge, parity and time, combine in perfect balance. To say it softly, if our universe spins clockwise through time, This twin spins counterclockwise. It's a subtle, haunting idea. Imagine that the Big Bang was not one explosion but two, mirror images expanding away from each other in time. From the center, one universe flows forward, ours. The other flows backward, its timeline unfolding in reverse. To us, that twin cosmos would appear to run backward, but to its own inhabitants, time would still feel normal. Suns would rise, lives would unfold, civilizations might wonder about their own mysterious beginnings, never realizing that their future is our past. This reflection isn't just poetic, it emerges naturally from the mathematics of symmetry. Every fundamental law of physics, except a few involving tiny interactions, remains unchanged if you flip all charges, mirror all directions, and reverse time's arrow. It's as if the universe insists on having a partner, a balanced counterpart to preserve its harmony. We can try to imagine this pairing through simpler analogies. Picture a painting made of two halves. One side shows the dawn, the other the dusk. The colours mirror each other, but where one brightens, the other fades. Together, they form a whole image, a cycle of light and dark. The universe and its mirror might be like that, two halves of a single cosmic artwork, where time itself provides the symmetry line. In such a vision, the Big Bang is no longer a singular beginning but a moment of perfect balance, where two arrows of time diverge like ripples, moving away from the same stone dropped in still water. This symmetry point, the stone itself, is timeless, a boundary where both universes are born. From that point on, each universe develops independently, one flowing forward, one backward, though from within neither side would notice any reversal. There's something quietly moving about this concept. It suggests that the universe doesn't need to prefer one direction or another. Both are equally valid, equally real. What we call the past and the future may just be perspectives from one side of the mirror. Somewhere, perhaps beyond the reach of light, another cosmos hums the same tune but plays it backward, like a record spinning in reverse. This reflection also offers an elegant explanation for one of the great mysteries of physics, why the universe began in such an ordered state. In our world, entropy, the measure of disorder, increases over time. That's why time feels like it moves forward. Things naturally spread out, cool down, become more disorganized. But if two universes were born together, their arrows of time would point in opposite directions, each experiencing growing entropy relative to itself. The symmetry would be perfect. From the outside, the two would look like mirror opposites. From within, each would feel natural. It's humbling to think that what we call forward may only be one side of a deeper balance. We are so used to seeing time as a current carrying us one way, yet perhaps it's more like a tide that flows in two directions at once. You might even say that the Big Bang was not the start of time, but the meeting point of two rivers, one flowing toward us, the other away, forever diverging, forever reflecting each other. If this mirror cosmos exists, it raises curious questions about connection. Could there be traces of it in our own universe, signatures left behind from that shared birth? Some physicists have searched for patterns in the cosmic background radiation, tiny anomalies that might whisper of another universe intertwined with ours. So far, the evidence is uncertain, the whispers faint. But even the possibility adds depth to our understanding of what creation could mean. And if you let your imagination drift a little, you might wonder what existence would feel like on that other side. To its inhabitants, everything would seem as steady and normal as our own experience. They might build telescopes and look outward, just as we do, seeing galaxies receding and space expanding, never realizing they're watching time run the other way. Their stars might form as ours fade. Their future could be the echo of our past. In a way, the idea of a mirror universe is less about physics and more about perspective. It reminds us that direction is not an absolute truth but a relative experience. Just as up and down lose meaning in space, forward and backward may be illusions within a greater whole. The symmetry of existence doesn't need preference, it only needs balance. There's also something profoundly human about this. We too look into mirrors and see reversed versions of ourselves. They're not different people, they're us, seen from another angle. Maybe the universe is doing the same thing, reflecting itself across the boundary of time, ensuring that its beauty is complete. Perhaps that's why symmetry feels so calming to us. It reassures us that nothing truly stands alone, that every action, every motion has a complement somewhere, even if unseen. It's a quiet reminder that balance underlies everything, even time. When we look up at the night sky, filled with distant stars, we often wonder what lies beyond them. But maybe beyond isn't the right word. Maybe the real mystery lies not past the stars, but across them, in the unseen reflection that completes their story. And so, when we think about the Big Bang now, it may help to picture not a single flare of light, but two, bursting outward in opposite directions through the sea of possibility. One of them became us. The other became the universe's reflection. A world where time runs the other way, where dawn is dusk, and yet the symmetry remains perfect. From here, the story begins to turn inward again. For all these grand ideas, multiverses, cycles, mirrors, share one haunting question. What lies beneath them? What does the universe emerge from when all else is stripped away? The next step of our journey drifts toward that question, to the still, trembling heart of everything, to the nothing that isn't nothing at all. There's a quiet satisfaction in balancing something perfectly. The equal weight of two hands holding a bowl, the sound of a chord resolving after tension, the simple calm that comes when everything evens out. In physics, that kind of balance may not just be beautiful, it may explain why anything exists at all. Imagine the entire universe as an account book with only two entries. On one side you have energy, the bright positive kind that builds stars, lights the sky, and hums inside every atom. On the other side, you have gravity, the gentle, invisible pull that gathers things together. Gravity's energy is negative, which sounds strange, but it means that it balances the ledger. Every burst of light, every creation of matter is matched by an equal and opposite dip in gravity's curve. Together they sum to zero. That idea, first whispered by physicist Edward Tryon in the 1970s, is sometimes called the zero-energy universe. Tryon suggested something startling. The universe may have been free to create itself, because it didn't actually cost anything. It didn't borrow energy from anywhere. It didn't owe a debt to time. It was the perfect self-balancing act, the ultimate symmetry. If that sounds abstract, let's make it smaller. Picture a hill and a valley. If you scoop earth from the hill and pile it into the valley, you create both height and depth. The total change, the sum of the hill's rise and the valley's fall, is zero. You've shaped the landscape without adding or removing anything. The universe might have done something similar. Energy rose like hills, gravity sank like valleys, and together they shaped the landscape of existence, still summing neatly to nothing. You can see this balance playing out all around you. When a star burns, it radiates energy outward, but gravity pulls inward with equal grace, keeping the star in shape. When you jump, the Earth's pull and your own motion momentarily cancel out, forming a brief duet between weight and flight. Balance is not rare, it's the rhythm of everything. If you could somehow gather every particle of matter in the cosmos and weigh its energy, then do the same for every gravitational field pulling it all together, you might find that the total energy of the universe adds up to nothing. Not a metaphorical nothing, but a genuine net zero. The positive and negative cancel perfectly. Creation, it seems, didn't need a down payment. It's a simple yet profound possibility. Maybe the universe didn't come from something or nothing. Maybe it came from a perfect equation that always equals zero, a whisper of symmetry, resting so evenly that it didn't need a push to begin. In that way, the Big Bang wasn't so much a spark as a balancing act, an unfolding of positive and negative energy that, together, make a cosmos while still summing to zero. This balance also helps explain why the universe can expand without running out of fuel. As space stretches, gravitational energy becomes more negative, matching the increasing positive energy of matter and light. Like a dancer spinning faster as her arms draw in, the cosmos adjusts itself automatically, conserving the total harmony. Tryon once put it this way: the universe is simply one of those things that happens from time to time. He didn't mean it casually. He meant that if the laws of physics permit such perfect balance, then universes could arise naturally from quantum fluctuations, tiny ripples in the vacuum that cost nothing because they borrow and repay energy instantly. What begins as a small tremor in the nothingness could, if it grows, become an entire cosmos, still keeping its books perfectly even. To imagine it, think of a still pond. Every now and then, a breeze stirs the surface, making small waves that rise and fall together. The water doesn't gain or lose, it simply moves, its total calm preserved in motion. The universe might be one of those waves, a temporary pattern rising from the vacuum, shimmering for a while, then fading back into stillness. Of course, that doesn't mean the universe is fragile or fleeting in the way a wave is. The physics of its expansion allow it to persist for billions upon billions of years, but the principle remains elegant. Its very longevity is sustained by balance. Gravity holds the canvas while energy paints the picture. There's something strangely comforting about this idea. It suggests that creation isn't a violation of nothingness, but an expression of it. Nothingness, in this view, isn't an empty void. It's a state of perfect equilibrium. Add a small disturbance, and the balance shifts into visible motion, yet the total remains unchanged. It's like silence turning into music. Even as notes rise and fall, the overall stillness behind them never disappears. We tend to think of nothing as absence, a vacuum devoid of meaning. But maybe it's the opposite. Maybe nothing is full of potential, the way a blank page is full of stories it could hold. The universe, then, is just one such story written briefly across the stillness. And what happens to balance over time? Does the universe eventually tilt? So far, it doesn't seem to. The expansion continues, the scales remain even, and the sum stays near zero. Like a tightrope walker who never wobbles, the cosmos has found a strange equilibrium that endures through its own motion. For us, this balance offers a quiet lesson. We often imagine life as a struggle between gain and loss, as though value only comes from accumulation. But the universe shows another way, perfection through cancellation. The hill and the valley complete each other. Energy and gravity sustain each other. Light exists because darkness balances it. In that sense, creation is not a triumph over nothing. It is nothing, shaped into something that knows itself. Every atom, every moment is the meeting point of opposites, summing always to zero. So perhaps the reason existence costs nothing is because nothing was ever truly lost. Every joy, every sorrow, every shining and fading is part of a balance that is never tipped. The universe doesn't owe its being to luck or miracle. It simply balances perfectly on the edge between presence and absence. This story of nothingness, though, doesn't end here. Beneath that balance lies motion, fluctuations, instability, a restlessness that never stops stirring the void. From that restlessness, bubbles of creation can form, whole reality shimmering into being. The next part of our journey steps into that trembling sea, to see how nothingness can suddenly decide to move, and in moving, become everything. If the universe truly balances at zero, it still leaves one lingering question. Why did the stillness ever move? Why did perfect balance decide to become motion at all? In physics, there's a concept called the false vacuum, but don't let the name fool you. It isn't empty. Imagine a calm pond, smooth and motionless. To the eye, it looks stable. Yet beneath the surface, tiny ripples wait, invisible and restless. The false vacuum is like that. It's a state that seems like the lowest possible energy, the quietest possible version of reality, but it's not quite the true resting place. Somewhere deeper, even calmer possibilities exist. You can think of it like a marble resting in a shallow dent on a hillside. It appears still, perfectly settled, but there's another lower valley nearby hidden by a small ridge. For a long time, maybe billions of years, the marble stays where it is, caught in its false balance. Then by chance a slight tremor, perhaps a quantum fluctuation, nudges it over the ridge. The marble rolls gently into the deeper valley. The fall releases energy, and what was once a static landscape suddenly stirs. That motion, the marble's roll, is what physicists call quantum tunneling, the universe finding a new way to express its balance. In our cosmic story, that leap could have been the moment when everything began, the instant when the false vacuum slipped into the true one, releasing a flood of energy that inflated space itself. To picture it, imagine a still pond covered in mist. Then, somewhere on its surface, a bubble forms, small and perfect, a globe of shimmering water that pushes outward. Inside that bubble, the energy state is different. It's the true vacuum. The bubble expands faster and faster, swallowing the calm surface around it. Its walls are made of transition, the border between what was and what's becoming. Inside the bubble, a new universe begins to unfold. Outside, the old state fades away. This imagery sounds dramatic, but the process is utterly silent. There's no explosion, no thunderclap, only the quiet reconfiguration of energy, the way fog slowly turns to rain without a sound. The false vacuum doesn't vanish in violence. It evolves into something new, as naturally as a sleeping mind drifts into a new dream. Physicists suspect that our own universe might have begun this way, one bubble in a vast ocean of vacuum energy, and if that's true, then it may not be the only one. The quantum landscape might be full of such bubbles, each forming, growing and cooling into its own distinct cosmos. Some expand forever, others collapse quickly. A few, by some gentle alignment of conditions, may find the delicate balance that allows galaxies and life. Each bubble carries its own laws of physics, its own possibilities for time and space. In this vision, creation isn't a single, unique event, but an ongoing process, bubbles appearing in the sea of possibility, like stars reflected on the surface of dark water. Our universe could simply be one among countless others, each expanding within its own horizon, unaware of the rest. But this idea carries another, quieter implication. If the false vacuum gave birth to our universe, then our reality might still contain its ghost, a lingering instability. It's possible that we too are living in a state that only appears to be the true resting point. Somewhere out there, perhaps across unimaginable distances, the universe could one day tunnel again, slipping into an even deeper valley of calm. That thought can sound unsettling. The idea that reality itself might someday change, that the very fabric of physics could shift beneath us. But there's no reason to see it as catastrophe. If it happens, it will be smooth, silent and instantaneous, more like a change of dream than a collapse of world. The laws of this universe would simply dissolve into new ones, as naturally as night turns into dawn. There's a kind of comfort in that too. It means that even the universe isn't fixed. It's alive in a way we rarely imagine. It can change its state, adapt, reconfigure. What we call reality is just one stable moment in a much larger cycle of transformation. And though it might seem abstract, the false vacuum has a strangely human echo. How many times in our lives do we rest in places that feel stable, but aren't truly at peace? We stay where we are, thinking it's balance, until one day something inside us shifts, a realization, a chance, a quiet tremor, and we roll into a new way of being. That change can feel frightening, even destructive, but often it's simply the universe expressing itself through us, seeking the deeper valley of calm. You can think of the false vacuum as the universe's hesitation, the pause before movement, the long breath held between potential and release. It's the moment before dawn when the air feels tense with waiting, when the sky is not yet light, but no longer dark. And when the leap finally happens, it's not the end of quiet, it's the quiet learning how to become emotion. This understanding turns the idea of nothingness on its head. Even the vacuum, even what we call empty space, isn't static. It seethes with hidden energy, restless with possibilities, always one heartbeat away from transformation. That restlessness is creation's raw material. The universe, in its deepest essence, may not be a place at all but a process, a continuous movement from false balance into true harmony again and again. So maybe the Big Bang was not a single event long ago, but one moment in an infinite series of awakenings. Each time the false vacuum slips into truth, another bubble of reality forms, glows, and grows. Somewhere, out there beyond our horizon, new universes might be blooming even now, each one the silent shimmer of a dream becoming real. From here, our journey begins to shift again, moving from energy to connection, from how the universe was born to how it holds itself together. Beneath all these fields and transformations, there's a deeper pattern, a web of relationships that binds even distant particles into one shared reality. In that web, distance dissolves, and connection becomes the true structure of existence. If you tug gently on one corner of a spider's web, the whole structure trembles. The vibration travels through invisible threads, reaching places far from where the movement began. Nothing within the web exists in isolation. Each strand depends on the others for shape and strength. In the same quiet way, the universe seems to hold itself together, not through solid walls or boundaries, but through invisible relationships that link everything to everything else. Physicists call this entanglement, though the word hardly captures how strange and beautiful it truly is. In quantum mechanics, two particles can become connected so deeply that they act as one system, even when separated by vast distances. If you change one, the other responds instantly, as though they're sharing a secret across the void. Einstein once called this spooky action at a distance, a phrase meant half in jest and half in disbelief. But experiments since then have confirmed it beyond question. The universe is a web of connection, and its threads reach farther than light or time should allow. To make sense of this, imagine two dancers who practice together so perfectly that even when placed on opposite sides of the planet, they still move in sync. Each gesture of one is mirrored in the other, not because they send signals back and forth, but because they share the same choreography, written into them from the beginning. Entanglement works like that, a choreography of existence, encoded from the moment particles interact. Now, the truly astonishing part is that these connections might not just link things within space, they might create space itself. This idea is known as emergent space-time. It suggests that what we think of as distance, direction, and geometry may arise from patterns of entanglement. The fabric of the cosmos isn't made of threads of matter, it's made of relationships. It's a concept that turns our intuition inside out. We usually imagine space as a container, a vast empty arena where things happen. But according to this view, space doesn't exist first. It's born from the way things are connected. The more tightly two regions of the universe are entangled, the closer they feel. Where the connections weaken, space stretches. It's as if the universe were a great tapestry woven from relationships, not from substance. Think about a friendship that endures across distance. You may live worlds apart from someone, but when you speak, the feeling of closeness is instant, unchanged by miles. In that moment, distance dissolves. Entanglement is the cosmic version of that. Two particles separated by galaxies, yet joined in a bond that ignores the rules of separation. In laboratory experiments, this effect shows up again and again. When entangled photons are sent in opposite directions and one's orientation is changed, the other reacts instantly, as though the universe refuses to let the connection break. It's not that information travels faster than light, it's that the two are still part of the same whole. The universe, it seems, has no interest in treating them as separate things. Some physicists believe that the geometry of black holes, the mysterious curvature where space folds in on itself, can be explained entirely through entanglement. The same goes for the fabric of space-time itself. The structure that defines where and when events occur might be woven by the network of these quantum relationships. Each knot, each intersection of connection, defines a point in space. Without the connections, there might be no where at all. It's a humbling thought, that what we call reality could be less like a physical landscape and more like a grand conversation. Every particle, every field, every flicker of energy is a word in an ongoing dialogue. Space is the grammar that arises from that exchange. You and I, stars and atoms, light and gravity, we're all sentences written in the same language of connection. Even more quietly, this view hints at something profound about human life. Our relationships, the bonds we form, the ways we affect one another, may not be metaphors for the universe's design. They may be reflections of it. The cosmos itself is relational at its core. To exist is to be in contact, to be entangled in the web of everything else. The closer the connection, the less distance matters. And like the quantum world, those connections aren't always visible. You can't see the threads of gravity that bind the moon to the earth, or the ones that tie memory to emotion. Yet you can feel them. The universe, too, feels its own connections, stretching and tightening in ways that define its very shape. If you could look at the cosmos not with eyes but with intuition, you might see it as a shimmering network, a luminous net of interwoven links, glowing softly at every intersection. Galaxies are knots in the net, stars are intersections, and the empty spaces between them are simply where the web stretches thin. And beneath it all, everything is still connected, still vibrating together like the pluck of a single, infinite string. This understanding shifts how we think about isolation. In truth, nothing stands apart, not even the loneliest atom drifting through intergalactic space. It is still tied, through gravity, through quantum connection, through the silent hum of the vacuum, to every other atom that ever was. The same principle holds for us. To be alive is to participate in the universe's pattern of entanglement, to touch and be touched across invisible distances. It's beautiful to think that even light, which seems to move alone through the dark, carries traces of these connections. The photons that warm your skin on a sunny morning have travelled across millions of kilometres, yet in their essence they're still part of the web that holds you, the earth and the sun together. You're always within the weave, and perhaps this is why the universe feels coherent, why everything, from the birth of galaxies to the beating of your heart, seems to follow one continuous rhythm. The music of existence is written not in notes of matter, but in the harmony between them. So maybe the next time you feel distance, between yourself and another person, or between yourself and the wider cosmos, you might remember that separation is an illusion of perspective. The threads of reality don't end where our senses do. They extend beyond, connecting us through quiet relationships we'll never fully see, but always inhabit. The deeper we look into the structure of the universe, the clearer it becomes. What truly exists is not things, but the spaces between them, the relationships, the resonance, the rhythm of being connected. In that sense, the universe doesn't contain love or gravity or light. It is those things woven together, and as this understanding settles, we begin to glimpse the edge of what can't yet be put into words, the point where equations fall silent and connection itself becomes the only remaining truth. That is where our next step leads, to the breath between those equations, to the moment when knowing ends and wonder begins. If you've ever listened to a symphony, you know the most moving moments often live not in the notes themselves, but in the pauses between them. The breath the music takes before continuing. Those small silences hold tension, release, and something even deeper: anticipation. In many ways, science is built on those same pauses. Between each elegant equation and brilliant discovery lies a moment of stillness, a place where understanding falters and mystery quietly breathes. Physicists have spent centuries crafting formulas to describe the universe, each one a kind of language written in the alphabet of numbers. Gravity, electromagnetism, quantum fields, all have been tamed to a degree by mathematics. But when those same equations are carried back toward the beginning of time, to the first instant of everything, they begin to shatter. Their symbols twist into infinities. The answers come out undefined. It's as though, at the edge of existence, the universe itself draws a soft curtain and whispers, "That's enough." Brian Cox once said that a singularity, a point where density becomes infinite, isn't a truth, but a confession. It's nature's way of telling us that our mathematics has reached its limit. Like a painter trying to capture the shimmer of light with brushstrokes too thick, our tools work until they don't, and beyond that, we can only imagine. Yet, there's beauty in this failure. The fact that our equations lose their breath at the dawn of time might not mean the universe is unknowable. It might simply mean that knowing is only part of what the universe does. Beyond the reach of logic, there may be a rhythm, a pulse, a truth that isn't written in symbols but in silence. To picture this, think of how you breathe. The inhale gathers what is outside of you. The exhale releases what's within. Between them is a small, still moment, a pause that isn't empty, but full of balance. The universe may breathe the same way, expanding, contracting, pausing, each expansion and exhale of light and space, each pause the breath between equations. Physicists sometimes talk about the theory of everything, the dream of uniting the laws of the large which govern stars and galaxies with the laws of the small which rule atoms and quarks. So far, that unification remains out of reach. Gravity refuses to merge gracefully with quantum mechanics. One theory describes curves and waves, the other probabilities and jumps. They speak different dialects of the same cosmic language, and somewhere between them lies the silence of misunderstanding. But maybe that silence isn't failure. Maybe it's the universe protecting the part of itself that must remain wild. Every story, every piece of music, every life needs mystery to stay alive. Without it, there would be nothing left to wonder about, and wonder is how consciousness breathes. Mathematics, for all its precision, can only trace the outlines of reality. The content, the texture, the warmth, the why, lies beyond the edges of calculation. We can write formulas that describe how stars shine, but not how it feels to see one fall behind a mountain at dusk. We can measure the frequency of a note, but not the way a violin sound trembles in the chest. There's a boundary between description and experience, and it may be that the universe's most fundamental truths live on that boundary. Even in science, many discoveries are born not from certainty, but from humility. Newton wrote equations for gravity, but never claimed to know what gravity was. Einstein curved space-time, but admitted he didn't know what space is. Quantum theory describes probabilities, but can't tell us what a wave function really means. It's as if every layer of knowledge, when peeled back, reveals another silence underneath, a deeper breath waiting to be heard. You can think of those silences as the spaces where imagination begins. Without them, equations would be cages. With them, they become windows. The unanswered questions, the why and the how, invite us to look closer, to dream further. They remind us that mystery isn't the enemy of understanding. It's the soil it grows from. Perhaps that's what makes the cosmos so endlessly compelling. It never tells us everything. It leaves room for curiosity, for reverence, for wonder. The same emptiness that our equations stumble over may be the very thing that keeps the universe alive. A blank page waiting to be written on, a pause that invites the next note. There's an image some physicists use when talking about quantum foam, the restless energy at the smallest scales. They say space itself boils with microscopic activity, particles appearing and vanishing like bubbles in a pot of water. But perhaps, beneath that boiling, there's stillness, a deep calm that holds the motion together. If we could see that level of reality, maybe it would feel like standing in the quiet between heartbeats, where everything vibrates but nothing rushes. And maybe that's what the beginning of time was like. Not a bang, not even a breath, but the pause before the breath, the delicate balance between potential and release. The equations break there because numbers can't describe waiting. They can't quantify anticipation, but the universe can. It lives in it. In this sense, the singularity, our supposed wall of understanding, is not a failure but an invitation. Beyond it might not be chaos but simplicity, a place where the universe folds its laws back into a single gesture, like a note fading into silence. To reach that place doesn't mean solving the final equation. It means learning to listen to what happens when the equations fall quiet. So, as the music of our journey softens, we might take comfort in knowing that the limits of knowledge aren't the limits of wonder. The breath between equations is not a void. It's the universe taking its time, savouring its own mystery before exhaling again into creation. And somewhere within that quiet breath, time itself begins to stir once more. The silence turns into motion, warmth, and memory. The arrow of time awakens, not as a rule, but as a rhythm. The next movement of our story begins there, where order spreads, where entropy grows, and where time learns how to move in only one direction. If you leave a cup of tea on a table and forget it for a while, it will slowly cool. The warmth moves outward, fading into the air until both tea and room share the same temperature. What never happens is the reverse. The tea never draws heat from the air to become hot again. We accept this without thinking. It's just how the world works. But behind that simple truth lies one of the deepest mysteries in all of physics, the direction of time. Why does time move only forward? Why can we remember the past but not the future? Why do things grow old, crumble, and spread out instead of reassembling themselves? To understand this, scientists turn to a principle called entropy. In soft terms, entropy is the measure of how spread out, or how possible, things have become. High entropy means disorder, but not in the sense of chaos, more like the tendency of things to even themselves out. Imagine you open a perfume bottle in a quiet room. At first, the scent is concentrated, trapped in a small pocket of air, but within seconds it drifts, disperses, fills every corner evenly. The air doesn't have to try. Diffusion is simply what happens when things have room to spread. The universe follows the same rule. It began in an incredibly ordered state, dense, smooth, and uniform. Over time, energy and matter have spread out, forming stars, galaxies, and eventually life. And as they do, entropy increases. To put it another way, time's arrow is really the arrow of spreading. The universe started like that bottle of perfume before it opened, contained, balanced, but full of potential. Once released, its contents could only move in one direction, toward greater possibility. Entropy grows not because the universe loves disorder, but because it explores every way it can exist. That's why we experience time as moving forward. Our memories record events in the direction of increasing entropy. An egg can fall and break, but the shattered pieces will never jump back together because there are countless more ways for them to be scattered than whole. When you watch a movie of an egg unbreaking, you instantly sense it's running backward. Your mind recognizes the direction of warmth, the flow from concentrated to dispersed, from improbable to probable, and yet there's something curious about this story. If we trace time backward toward the Big Bang, entropy decreases. The early universe was astonishingly ordered, a smooth sea of light and energy, nearly identical in every direction. The question that puzzles scientists is, why did it begin so organized? If randomness is natural, why wasn't the beginning a mess of uneven temperatures and tangled gravity? No one knows for sure. Some say that the Big Bang was a kind of reset, the moment when all complexity was compressed into simplicity. Others suggest that the arrow of time might flip in other regions of the multiverse, that in some parallel cosmos, entropy decreases instead of increases, and their future flows opposite to ours. In that mirror world, cooling tea might heat itself, and memories could run backward. But within each universe, inhabitants would still feel time moving naturally forward. It's possible that time's direction is not written into the laws of physics at all, but emerges from initial conditions, the way a breeze follows the shape of a landscape. The universe began in a low-entropy valley, and the only way from there was outward. We are the children of that spreading, tiny ripples in the wave of expansion that began when the cosmos first exhaled. There's something quietly poetic about this. The increase of entropy, which sounds cold and mechanical, is also the source of change, growth, and life. Every act of creation, from a star igniting to a child being born, depends on gradients, on differences in temperature and energy. A perfectly uniform universe would be perfectly still. Nothing could happen. Entropy gives time its texture. It allows stories to unfold. You can see this in the smallest moments. A candle burns because heat flows from its flame to the cooler air. A thought arises in your mind because chemical energy moves from concentrated molecules to diffused signals. Even our heartbeat is an entropy machine, using the imbalance of ions to push blood to sustain motion. Time's arrow runs through all of this. We live on its current, carried effortlessly forward. If you think of the universe as a vast ocean, entropy is the tide. It rises gently but never retreats. In the distant future, that tide will spread all warmth evenly until no energy remains to flow. From stars to atoms, everything will reach the same calm temperature. This is called the heat death of the universe, though the phrase sounds harsher than it is. It won't be fire or explosion that ends everything. It will be balance, stillness, perfect evenness at last. But before that final calm arrives, the arrow still points forward. Stars still burn, galaxies still spin, and we still move through the gradient of warmth and cold, possibility and memory. Time, as we experience it, is the sensation of that ongoing spread. The universe remembering how to forget its original order. There's a gentleness in that idea. We are in a way entropy made conscious. We carry within us the same principle that drives the cosmos. The urge to explore new configurations, to unfold from simplicity into complexity, to keep moving toward balance. Time is not something happening to us. It's something we are participating in, moment by moment. And so, when you watch ice melt in a glass, you're witnessing the most universal rhythm of all, the flow of possibility. The warmth doesn't vanish, it redistributes. The molecules don't die, they dance into a new arrangement. Entropy is not decay, it's transformation. In the hush of that understanding, the fear of time begins to fade. Its direction is not a countdown to ending, but a current of becoming. And even when that current finally stills, when the last star flickers and space settles into perfect calm, the memory of movement will remain. The arrow of time may rest, but the meaning it carried will echo in every atom that ever was. From that quiet echo arises one final question. If time flows one way, can it ever turn back? Is the cycle truly irreversible, or could the universe in some distant age loop into itself again? To find out, we'll have to step beyond the straight line and look for patterns that circle back, where endings fold into beginnings and eternity repeats itself like ripples returning to shore. Imagine standing at the edge of the sea, watching wave after wave roll in, each one dissolving into foam before another rises to take its place. No single wave is permanent, yet the rhythm continues without end. Some scientists believe the universe might follow the same rhythm, that time itself may not be a straight line stretching forever forward, but a circle, where each ending folds into a new beginning. The British physicist Roger Penrose calls this vision conformal cyclic cosmology, a name that sounds intricate, but its heart is simple. When one universe fades, another quietly begins. In Penrose's idea, the vast future of our cosmos, the time when every star is burned out and every black hole is evaporated, is not a final silence, but a kind of reset. When all matter is gone and only the faint massless light of radiation remains, the universe forgets its scale. Time and distance lose meaning. The cold, empty space that remains becomes strangely identical to the hot, dense conditions of a new Big Bang. It's like the universe shedding its skin. What we call an ending may be the same as what another cycle calls a birth. No great explosion, no divine spark, just a gentle transformation, the same energy rearranging itself into a new rhythm. The cosmos breathes out for eons, then inhales again, each breath lasting trillions upon trillions of years. You might picture it like ripples overlapping on a pond. Each ripple expands until it fades into stillness, but the energy of the movement is never lost. It merges with others, forming new waves. Every cycle of the universe is another ripple, a continuation of motion that never truly stops. This vision isn't just poetic, it's built on the mathematics of geometry. Penrose noticed that when the universe becomes incredibly large and cold, the shapes that describe space can be rescaled, stretched or shrunk without changing their essence. In that rescaling, the endless future and the fiery beginning start to look the same. The end of one aeon, he says, matches perfectly with the start of the next. The universe, in this view, doesn't end. It renews itself endlessly. Astronomers searching the cosmic microwave background, the faint afterglow of the Big Bang, have even found mysterious patterns, vast circular traces called Hawking points, or cosmic rings. Some think these might be echoes of black holes evaporating in a previous universe, leaving behind marks that survived the rebirth. The evidence is debated, but the idea itself feels hauntingly elegant, that our night sky could carry scars from worlds long gone, imprints of a time before time. To bring this closer to our human sense of experience, think of the changing seasons. Winter ends and spring begins, not with a single moment of transformation, but with a gradual blending, the last frost melting as new buds appear. The boundary between death and rebirth is soft, blurred by continuity. The universe's cycles might work much the same way. One cosmic winter sliding gently into a new spring, so smoothly that no observer could tell when the change occurred. There's something deeply comforting in this picture. It suggests that nothing is ever truly lost, only transformed. Every galaxy that burns out, every particle that fades into light, contributes to the birth of what comes next. Even the empty void plays its role, carrying the memory of what was into the possibility of what will be. In a circular universe, time itself becomes more like music. A song may end, but its melody can be played again, each performance slightly different but woven from the same notes. The cosmos might hum like that, a timeless refrain repeating across ages. We, living within one verse of that song, can't hear its full shape, but we feel the rhythm beneath our days: creation, expansion, decay, and renewal. If you imagine the night sky not as a snapshot but as a memory, you might sense this continuity. The light that reaches us from distant galaxies is already ancient, millions, sometimes billions of years old. It carries the story of stars that may no longer exist, their radiance still crossing the darkness long after they've gone cold. Each photon that touches your eye tonight could be one of the last whispers of a vanished world. Yet through that whisper, something of that world continues. In this way, even linear time contains hints of the circle. Penrose's idea also redefines what it means for the universe to die. The final state where matter dissolves into light is not destruction but simplification, a return to the same symmetry that allowed creation in the first place. Once again, everything becomes pure geometry, pure potential. Then, without effort, a new phase begins. The cosmic clock doesn't reset, it continues without ticks or tocks, only an eternal flow. There's a quiet resonance between this theory and the way life itself works. Our bodies are built from recycled stardust, atoms forged in the hearts of stars that died long before Earth was born. Every breath we take carries particles once exhaled by oceans, forests, perhaps even ancient worlds. Life, too, is cyclical. We are part of the same renewal the universe performs on a grander scale. If eternity isn't an infinite line, but an endless series of circles, then perhaps death, whether of stars, people, or universes, isn't absence but transition. The matter that forms you will one day scatter into space, but its story will continue folded into new forms. Energy never vanishes, it simply changes key. When viewed this way, the end of time doesn't feel cold or tragic. It feels serene. The universe doesn't race toward oblivion. It moves toward renewal. Just as dusk becomes dawn for someone on the other side of the world, one universe's farewell might be another's first light. And so, the arrow of time, which seems so definite and one way, begins to curve gently back on itself. The straight road becomes a loop, the line a spiral, and everything that ever was becomes part of a single, continuous whole. If you listen closely, you might even feel the rhythm of it now, the slow expansion of your own breath, the rise and fall of your chest echoing the universe's pulse. You're not separate from this cosmic cycle. You're part of its recurring harmony, a single heartbeat in the endless music of being. Soon, our story will turn toward the far horizon, to the limits of what we can see, the edges not of time, but of sight. There, beyond the galaxies, we'll find the quiet boundaries of our knowledge, horizons that hide more than distance, and futures that stretch into the unknowable calm where beginnings are born again. There is a point, far beyond what any telescope can see, where distance begins to blur into meaning. It's not a wall or a border, more like a soft fog that thickens with each billion light years until even light itself cannot cross it. Astronomers call this the cosmic horizon. It isn't something the universe built to keep us out. It's something that appears because of how space expands. Beyond that line, the galaxies are not gone. They're simply moving away faster than their light can ever reach us. You might think of it like standing on the shore during a foggy dawn. The sea continues endlessly, but at some point it fades into grey. You can sense there's more beyond, but you can't see it. The horizon is not an edge, It's an illusion created by distance and light. The universe works the same way. As it grows, space itself stretches, carrying galaxies with it like beads on an expanding thread. Light from the most distant ones has been travelling toward us for billions of years, but the thread keeps stretching faster than the light can close the gap. What we see is the echo of a long-vanished moment, the sky as it once was. There are, in fact, several horizons in the cosmos, each a different kind of veil, marking the limits of what we can know. The first is called the particle horizon. It represents the furthest distance that light could have travelled since the universe began. Imagine a sphere centred on Earth, about 46 billion light-years in every direction. Everything inside that sphere is part of our visible universe, our cosmic neighbourhood. Everything beyond it exists but remains forever hidden. We can't see those galaxies, not because they aren't there, but because their light hasn't had enough time to arrive. Then there's the event horizon, a more haunting kind of limit. It doesn't describe what we can see now, but what we can ever see. As the universe's expansion accelerates, driven by dark energy, distant galaxies will eventually slip beyond our reach, not just visually, but causally. No signal, no light, no message could ever travel from them to us again. They will fade from our reality, not by vanishing, but by receding into a realm forever disconnected. It's as though the universe is gently dimming the lights, one cluster at a time, until only our local group remains visible, a small island of stars surrounded by eternal darkness. The third horizon, the Hubble horizon, is the most dynamic. It defines the boundary where galaxies move away from us at the speed of light due to cosmic expansion. But this horizon isn't fixed. It changes as the universe evolves, expanding and contracting depending on how quickly space itself grows. In that sense, it's less a line and more a breath, a cosmic pulse that measures how far our vision can stretch before fading. To picture all this, imagine the universe as a vast ocean at night. You're in a small boat, holding a lantern. The light illuminates a sphere around you, the world you can perceive. Beyond that sphere, the darkness remains, silent but present. As your boat drifts and the sea expands, your lantern's glow touches less and less of what lies ahead. The sea itself doesn't end, but your reach does. And yet, not all signals respect these boundaries. Some messengers are stubborn enough to cross them, whispering from beyond the fog. Neutrinos, tiny ghost-like particles born in nuclear reactions, pass almost unhindered through matter. They can traverse the densest walls of stars and planets, carrying information from places light cannot escape. Even more elusive are gravitational waves, ripples in space-time itself caused by massive events like colliding black holes. They travel not through the universe, but as the universe's own vibration. When we detect one, we're not hearing a sound that travelled across space. We're feeling the space itself shiver. These signals, faint and ancient, act like letters slipped under the door of the cosmos. They remind us that even when light cannot cross, meaning sometimes can. The universe, it seems, always finds a way to speak across its own horizons. And perhaps we too have our own horizons, boundaries of understanding that expand as we learn, yet always leave something beyond reach. Each discovery widens our visible world, but also deepens the mystery that lies outside it. Knowledge is like light. It illuminates, but also casts new shadows. When astronomers talk about the edges of the observable universe, they speak in numbers almost too vast to hold in the mind. Billions of galaxies, each with billions of stars, stretching across distances measured in light years multiplied by tens of billions. Yet the most humbling truth isn't how large the universe is, it's how much of it we'll never see. Even if we could live forever, the accelerating expansion ensures that more and more of the cosmos will drift beyond our reach. We're watching a grand theatre whose stage is slowly dimming, one curtain at a time. But that isn't a reason for sorrow. There's a quiet grace in limitation. Without horizons, there would be no wonder, no yearning to know what lies beyond. The unseen gives meaning to the seen, the same way silence shapes music. The fact that our universe hides parts of itself doesn't make it less beautiful. It makes it infinite in a more intimate way. It tells us there will always be more to imagine, even if we can't touch it. And perhaps, in some subtle sense, curiosity itself is a form of light, our own inner radiation, forever trying to cross the boundaries of what can be known. Just as photons journey across the expanding cosmos, our questions travel beyond the edges of understanding, reaching into the unknown. The answers may never return, but the act of asking, the act of looking, is its own kind of illumination. If you close your eyes for a moment, you can picture the horizon not as a barrier, but as a mirror, reflecting the faint glow of all that we do not yet comprehend. The further we look, the more the universe invites us to listen, not just to what can be measured, but to what can be felt. And so we drift onward, tiny observers on a pale blue world, surrounded by layers of invisible fog, illuminated by our own fragile lanterns of curiosity. Beyond every horizon lies another, and another still, each one reminding us that knowledge is never a destination, only a direction. In the next breath of our cosmic story, we'll reach that direction's end, or rather its beginning again. We'll watch as stars fade, black holes evaporate, and the universe exhales into stillness. And then, perhaps, we'll find that even in the final quiet, something ancient stirs, the promise that every ending is just the start of another dawn. If you step outside on a clear night and look up, it's easy to imagine the universe as eternal, a tapestry of stars frozen in their places, unchanging, infinite. But like all things, the cosmos has a life cycle. It was born, it grew, and one day it will rest. Yet this rest, as strange as it may sound, may not be an ending at all, but a quiet transformation, one final breath in the story of everything. Right now, the universe is still full of motion. Stars burn hydrogen into light, galaxies dance through space, and black holes hum softly in the background. But every act of burning, every beam of light, every burst of energy comes at a cost, the cost of spreading. As entropy grows, energy becomes harder to gather, warmth harder to find. Stars exhaust their fuel and fade into embers. The bright spiral arms of galaxies begin to dim. One by one, lights go out, and the night deepens. This long twilight is the beginning of what scientists call the heat death of the universe. But it's not death as we imagine it. There is no catastrophe, no collapse, no scream of fire. It's more like a winter evening settling slowly over a landscape that once shone with summer light. The stars dim, not in tragedy, but in completion. Everything has released its energy. Everything has found rest. Trillions of years from now, only the faintest red stars will remain. Small, slow-burning embers glowing gently in the dark. Even they will eventually cool into black dwarfs, invisible spheres of carbon and oxygen, cold as the surrounding space. Planets, moons, and asteroids will drift silently, circling shadows instead of suns. It will be, in every sense, the universe's nightfall. But the story doesn't stop there. In the distant dark, black holes will become the last actors on the cosmic stage. They are not eternal either. According to Stephen Hawking's insight, they leak away energy over unimaginable timescales through a process known as Hawking radiation, a soft, slow whisper of heat that eventually unravels them. It's as though even gravity itself, after holding the universe's secrets for eons, eventually sighs and lets go. When the last black hole finally evaporates, all that will remain is a thin haze of particles stretched across space like the faint echo of a memory. No stars, no galaxies, no light, only a uniform calm. This is what physicists call maximum entropy, the point where energy is evenly spread everywhere, where nothing new can happen. It is the perfect balance, the perfect stillness. And yet, this stillness carries its own strange beauty. A universe that began as a hot, roaring storm will end as a cool, silent sea. You could say it returns to the same peace it once emerged from. After all the explosions, the collisions, the births and deaths of countless suns, the cosmos finds equilibrium again, a circle, closing gently on itself. In that silence, perhaps the universe becomes what it was before it began, a place of potential, of possibility waiting to be stirred. Quantum theory suggests that even in perfect emptiness, tiny fluctuations can still occur. Small, random tremors in the vacuum. Most fade instantly, but once in a while one grows. It expands. It becomes something. Out of quiet, movement returns. Out of stillness, breath. Out of nothing, everything once again. So maybe the heat death isn't the end, but the beginning of another cosmic cycle. A new universe blooming from the ashes of the old. The same laws of balance, the same dance of energy and gravity start again, shaping new galaxies, new stars, perhaps even new minds wondering about their origins. The universe may not remember its previous version, but it carries the same pattern, the same symmetry, like music starting over from its first note, familiar yet freshly alive. There's something profoundly reassuring in that possibility. It means that endings, no matter how absolute they seem, are never wasted. The energy that builds, fades, and disperses always finds its way back into the rhythm of creation. Even the quietest void hums with the memory of what was and the promise of what might be. You can see echoes of this on smaller scales everywhere. A forest burns, and from its ashes seedlings rise. The tide recedes, and new shells glimmer on the sand. Even in our own lives, endings make space for beginnings. The universe, vast and ancient, follows the same compassionate rule. If you were to drift through that far future cosmos, when all stars have faded, you wouldn't find darkness empty or cold. You might instead feel a deep serenity, a sense that everything has come home. The radiation left behind would be faint but uniform, a soft cosmic glow at just a fraction of a degree above absolute zero. Like the last embers of a fire, it would whisper that warmth once existed, that stories once burned here. And if, one day, another fluctuation stirs, if a new Big Bang blossoms from that quiet sea, it may carry within it the faintest echo of us, of this moment, of every breath ever taken in wonder. We would be part of its foundation, its memory folded into light. So, when we think of the universe ending, perhaps we shouldn't picture darkness swallowing light, but light learning to rest. The cosmos is not racing toward oblivion, it's gliding into stillness, the way a song fades into its final note. The silence that follows isn't absence, it's completion. And within that completion lies the promise of another melody waiting to begin. And so, as we close this long journey, from the birth of everything to the quiet of forever, remember that you too are part of that rhythm. You are stardust burning briefly into consciousness, a fragment of the universe reflecting on itself. The same forces that shaped galaxies also shaped you, and when your time here ends, you'll return to the same balance the stars know, not lost but transformed. Perhaps that's the true secret of the cosmos, that nothingness is not the opposite of being, but its promise. The end and the beginning share the same silence, and within that silence the story never truly stops. So as you drift now, whether you're still awake or already half dreaming, take a deep breath. Feel the warmth of existence linger for a moment longer, then let it dissolve into calm. The stars are resting, the universe is breathing, and you are part of that eternal peaceful exhale.